All right, we're going to talk about probability in our next unit and what probability means. Many of you watched the video yesterday and did the Ed puzzle, so you kind of have a really good idea of it. I'm going to go through exactly what you're going to need to know for this unit and what's going to be expected. So probability is the chance of something happening. So the chances of it raining tomorrow, the chances of putting things together and one event happening based on what happens with another event. A lot of professions use this, such as designers, figuring out like what types of arrangements clothes can have, or businesses, maybe they want to have a varied menu and things like that. So the basics of probability, a lot of it is just logic, and some of it is just common sense, and you'll ask yourself, well, that was easy. Some of it is logic. Some of it is you have to know how to simplify. You have to know your prime numbers. You've got to know some of the basic things. Use the tools that you have. I posted some notes that have some tools on there on the tables with dice and with cards and all kinds of different things that you would be asked to do. So throughout this unit, we're going to talk about theoretical probability, experimental, complement, simple probability, compound probability, independent probability, dependent probability, and that's okay if you don't know what all those are, because I'm going to tell you what they are. Probability is what you want over the total possibilities. So this right here is just another fraction bar. Basically, your total possibilities is your whole, and what you want is your part. So I want to know if I throw a die that has 6 sides on it, if I were to throw it, my total possibilities, I could land on any number 1 through 6, but what I want is, maybe I want it to the probability of rolling a 2. So the probability of rolling a 2 is 1 out of 6. It's that simple, guys. And we're going to go through a lot of this right now. So words for you, a set of dice are 2. That's a plural for dice, or that's a plural for die. If you have one 6-sided cube, that is called a die. And we use that 6-sided cube as something that you'll use quite a bit. So the likeliness of something happening based on the possible outcomes is called theoretical. And so what that means is, in theory, this should happen. So like I said a minute ago, if I roll that's supposed to be a die. If I roll a die, at the probability, and this is how you will see probability questions asked to you, that P is no longer a variable for this unit. That just means probability. So it means that what is the probability of me taking a 6-sided fair cube and rolling it and getting a 5? So the probability of me getting a 5, there are 6 outcomes, but there's only one 5 on there. So in theory, theoretical means before I do anything, if I were just to look at it, what do I know about that? So theoretical is, in theory, I should be able to roll it and I should get a 5 1 out of 6 times. That's what theoretical means. It's before you do anything else, before you roll it, before you do anything. The likeliness of something happening based on an experiment that you have done. Well, the key word is experiment. So we've got experimental. Why is that T not? Okay, oh my God, that's not even spelled right. Okay, experimental. So experimental probability is after you have figured out, in theory, this could happen, what actually happened. So it's just like science. You've got a hypothesis. You try to decide you try to figure out, okay, I'm going to guess that this is going to happen based on what I already know. I already know that water is water, and I know that hydrogen is hydrogen. If I put them together, if I put 2 hydrogens together, I'm going to get water. I already know that. But if I do the experiment and pull two hydrogens together, am I really going to get water? Well, the answer is yes, because it's been proven yes. For experimental probability, it's the same thing. Theoretical means that what could happen. Experimental is what actually happened. So an example of that is this: Joe made a basket the last 6 out of 10 tries. Based on this, what is the probability that he will make a basket on his next shot? So he made 10 shots. That was his total. And if you remember from where we were doing is over of and things like that, the of, that's your whole. So he made 6 baskets. So the probability of making the next basket on the next shot is 6 out of 10. If you gave me this answer, I would mark it wrong because you do have to simplify. That is one key thing with probability that you have to be able to do. So you need to know your math facts. So we're going to divide this by 2, divide both sides by 2, and you get 3/5. So the probability of the next shot being making the basket would be 3 out of 5. All right. Then we've got something called complement. So a complement is something that goes. It's the other. It's the thing that we're not asking for. So just an example of that. There are 3 yellow marbles. So there's 3. There are 5 green marbles. And with probability, I have to write everything down because it's just easier for me to see it once I've written it down. So there are 3 yellow, there are 5 green marbles. When you write your answer, you have to write it in this form. For probability, it will be counted wrong, and it doesn't mean probability if you do not write it out like this. It means something completely different. So the probability of this one is not asking for probability. This is asking what the complement of getting a green is. Well, how many green are there? There are 5 green. And the opposite of that would be that what's the probability of getting not green? So yes, it is asking for the probability. So this is how you would write it. You would write the P, open parentheses, and write not green in there. Well, how many are not green? There are 3 that are not green, and there are 8 total. That's your total outcomes. Because if I were to pull those out, there are 8 in there. So the probability of me not getting a green is 3/8. Complement means, that's EMNT. Complement means the opposite, or the not. So keyword in here, what is the complement? Well, you need to know that means not. All right, the probability of just one event happening. That is called simple, because it's just one thing. So simple probability is the probability of just one thing happening. So we have 4 red cards, and we have 8 green. What is the probability of getting a green card? So the way you would write that is the probability of a green card. Yes, you have to write the P, the parentheses, and green in between in order for it to be a probability question. You don't write that, it's no longer a probability question, you would get it wrong. There are 12 cards. That's my total outcome. So that's my sample space. And the probability of me getting a green, because only one event is happening, I'm going to go pull a card, and I want to just do it one time. So the probability of me getting a green is 8 out of 12. Again, this can be simplified, and it will be counted wrong if you do not. So 8 divided by 4 is 2. 12 divided by 4 is 3. So the probability of me getting a green card is 2/3 in this situation. One event is happening, one card is being pulled. All right, the probability of two things happening. So when we were working with compound interest, we were compounding interest year after year after year. Same thing here. Compound means more than one. So compound probability is when two things are happening at once. So if I get two dice, or if I get a set of dice and I throw them, two dice are being rolled on the floor, or on the table, or wherever. So those are two events happening at the exact same time. So we've got a situation here where there are 5 red cards, 5 red, 3 blue, and 2 white. So I have altogether, I have 10 cards. That's my total outcome. That's my sample space. That's the sample that I'm using. That's how many cards I have. So the question says there are 5 red cards, 3 blue cards, and 2 white cards. What's the probability of getting a red card? So you would write that as the probability of getting red and then blue. So two events happening at the same time. This is called an independent event. So what an independent event means is that it is independent of whatever the other thing is happening. So I'm taking a red card, and then I'm going to get a blue card if you replace the card after the first time. So my sample space is not going to change. I'm going to take a red card, which is 5 out of 10, and then, so the words and then, or the word and, means to multiply. So if you want to write that somewhere, the word and means to multiply. So what happens with the blue cards? Okay, so then, and then, blue. So there's 3, 10. Well, now it's just a multiplication of fractions. So we can actually simplify this by 5 divided by 5, that equals 1. 10 divided by 5 equals 1. So that simplifies to 3 times 1, that's 2, sorry. 1 times 3 is 3, and 10 times 2 is 20. So the probability of this happening is 3 out of 20. So the key word you need to remember is the word and that means to multiply. This right here, you have to write it every single time, guys, and I can't stress how important that is because otherwise it is not a probability question. All right. Another compound event that could happen is something that is dependent on what happened in the first situation. So it is called as dependent. So that means that when I do the second thing, it's dependent on whatever happened on the first thing. So there's still 5 red cards, and there are 3 blue, and 2 white. I still have 10. That's my total outcomes. And that's my sample space. And the question is asking, what is the probability if I take a red card and then I told you that means to multiply a blue card? So the probability of me pulling a red and then a blue card, we got to finish reading the question. If you do not put the card back after the first time. So it's dependent on whatever happens the first time. So there are 5 red cards out of 10. Let's assume that I did pick a red card, or that I did pick a card, or that I got a card out of there. The word and then still means to multiply, but now if I didn't put it back in, my total outcome has changed. There are now 9 cards in there. So the blue cards were 3, so there were 9 cards left in there. We can simplify this down. So 3/9 is really, if I divide that by 3, that's 1. I can divide that by 3, that's 3. So 5 times 1 equals 5, and 10 times 3 equals 30. And I could have simplified it a little bit further, but 5 over 30, I need to simplify again. 1 over, oh my goodness, 1 over 6, sorry. So the probability of these 2 events happening is 1 out of 6. So I could have simplified that and that, divided by 5, and that equals 1. 10 divided by 5 equals 2. So that would have been 2 times 3, which is 6, and 1 times 1, which is 1. So there's a quick overview of probability. Use these tools to help you with the unit. And if you have any questions, let me know. Have a great day.